G'day, quantum mates. This is Hamak Yingli, your Quantum Odyssey tour guide. Got some good news that today is Easter. It's the Easter of the International Year of Quantum Science and Technology. And I have some very special announcement for you. So there will be an Easter roadmap and an update on how the future sessions of the 50 will be structured. In response to the YouTube analytics, and the potential future plans of this series. So already like this basket over there, I've drawn that using my virtual drawing pad painstakingly, and you can see like already like there are some quantum Odyssey motifs, these cross hatchings and the alternating colors. You can see the elements of the S gate, the Z gate, the X gate, and of most importantly the Y gate on the bottom. And remember, don't put all your eggs in one basket. But today it is an exception. So, you know, Easter is the only time where it is perfectly safe to put all of your eggs in one basket. This is said by Evan, quoted by Evan Izar. But let's go to today's topic. So today, as I said, being a holiday, it will be a diversion of the Quantum Odyssey material. In particular, the episode plan will be the first topic, because it is in concern with the YouTube analytics. Because as far as I know, the YouTube analytics does not look too good in terms of impression click-through rate and in terms of audience retention rate. So these are the two considerations I have to make. So these over there, thank you everyone for those who have subscribed to my channel. It will greatly appreciate my willing to continue this series. But as I said, this is the video analytics for the pilot episode. So I already gained 7 subscribers from that, and this has been posted on LinkedIn. However, considering the reach, notice that LinkedIn contributed to more than a fifth of all the viewerships. Actually, more than a third, because there's LinkedIn Android over there. The impressions seems fine. The impressions click-through rate seems unremarkable, but here's what the views comes from. So views from impressions 20%. So it's decent. But what is concerning, however, is the engagement. The engagement, the average percentage viewed, is not good. It's in the single digits. So that means bad watch hours, as if watch hours is more important than the view count. Already there is a massive drop at the 30-second mark, and then already only 1 in 30 or so came here to watch the entire video. You can also compare this to the other videos, and it seems like this thing is average. But yeah, this is something in the style of Khan Academy, and this is basically a Khan Academy for a very niche topic. In this case, it's quantum computing, or more specifically, a game that is inspired by and is based on quantum computing. This is my announcement for the 50-day challenge in response to Microsoft's 50-day challenge, and right now I have not been fully consistent on my efforts. So I still need some time to catch up. The engagement and the reach impressions look decent, but this time, again, most of the traffic, more than half of the traffic came from LinkedIn. And that came from the CEO of Quarks Interactives, the creator of Quantum Odyssey. So engagement, similarly, it's like on the order of 5% to like 2%. And then there's but this time there are like notable troughs. So low retention rate. Maybe because my videos are too impromptu and I did not announce a live session. Now, for the re-recordings, it can get really bad. And these re-recordings came after the day 7, the special announcement, because I missed 3 days in a row. Again, retention is probably even worse. This time it's just flat out low. So you won't really like that. It has never even crossed above this halfway mark. Reach, now the impressions started really blowing up, but the views from impressions, the click-through rate is even worse. Literally, like even the content suggesting this video, very few of them, probably like none of them, have to do with quantum computing. So maybe YouTube's algorithm suggestion probably like sent it to the wrong audience. This one is not advertised on LinkedIn, so it might make a difference. But again, this is the audience retention. It's not good. It's not good. Again, it's low. That is one of the later videos that has been recorded backdated. So it's day 9. This one will be re-recorded to just feature the S-gate as part of my plans. So this one, now YouTube seriously wants to like ramp up my viewership count. And it looks like the views from impressions is just really horrible. It's horrible. Like content suggesting this video. This time, maybe it's a little bit better because it's like a lecture style video rather than like the shorts. Engagement, YouTube just refuses to give these engagement metrics. So what does this imply? This implies that I have to clarify my episode plan. Because as I said, the engagement metrics according to YouTube is not good. I just want to be blunt to you, it's not good. So the main concerns are poor audience retention rates. Which might because like the videos are probably presented like as a reference video, so people could just visit this, then just scroll to see like what problem they specifically have. They leave and then they just solve the problem, rather than learn quantum computing out of it. And the other one is poor. So that means sub 1% click through rate against impression spike, against impression search. So what does that mean? I have to change my strategy. So here's my current strategy so far. So for the first 30 seconds, what I will do is I will do some greetings So greeting and topic introduction. So that's the first 30 seconds. Now for the remaining 90 seconds. So that's going to be at the 2-minute mark. So for 0.30 seconds, so let's do the mark, start, 0.30 seconds is where I get to introduce what this topic is about. Introduction and definition. For example, let's discuss about the controlled gate that has been featured on day 8, which actually received like no views whatsoever despite being backdated. So I would say the controlled gate allows us to selectively apply a particularly unitary gate like the X gate, the Z gate, the Y gate, or like whatever like single qubit gate you want, based on the state of the control bits. For example, a controlled X allows you to apply an X gate on just one pair out of two in a 2-qubit system, rather than both pairs. So this is the classic control NOT gate. Now at the 2-minute mark, I will give an example, a simple example for you. So example 1, which uses only the topic. So topic only. So if I'm demonstrating that this day would be about the Y gate, the first example would involve only the Y gate. For example, a Y gate performs both switch in positions between like two lanes and turns two sigils of the same color to opposite colors. So blue becomes green and yellow, and then switch it to become yellow and green. So that's the Y gate. And then we could like try to like apply multiple Y gates in parallel to obtain this gate over there. And then identify how the number of ones and zeros, namely the net difference of those, determine how many quarter turns this sigil encounters. So this will be on the 2-minute mark, and it's going to be lasts like 3 minutes. So now let's try the 5-minute mark. So on the 5-minute mark, this time it's going to be example 2. So example 2 would combine past topics. For example, we could perform, let's say, an XZ means a phase shift gate. So XZ becomes equals a phase shift. So it becomes this. So let's say phase shift. This one will also last 3 minutes. Then at the 8-minute mark, 8-minute mark, we will go with our third example, which will be slightly more challenging. And it might be based directly on one of the topics, the puzzles on this corresponding electron or the follow-up electron. So more challenging example. From the game. And then after the conclusion, so conclusion will be, let's say, I'll give 1 minute for the conclusion. So, for example, if we conclude the Y-gate episode, we'll say this. So, Quantum Odyssey trackers, congratulations for completing the first ring, but this is only the beginning of your adventure. We will learn how to combine these basic quantum gates to construct useful quantum and classical algorithms and dig deeper into the mathematical foundation of quantum computing and quantum mechanics. So this will be the episode plan, the sample conclusion. Let's discuss about the future roadmap. So consider the future roadmap. As I said, I will not reveal the episodes beforehand. But what this episode eventually will feature will be, the first thing is quantum algorithms. So quantum algorithms, so everybody should be like familiar with quantum Fourier transform. And that means I can also like make an analogy with the classical counterpart, the Grover's search. So quantum Fourier transfer, this is also going to refer to against Fourier transform and fast Fourier transform in a follow-up. Grover's search, this would then be against classical search and binary search. Grover search. The other one will be about classical circuits, which is nothing more than implementing an AND gate, an XOR gate, an OR gate, and they're like inverses NAND, NOR, and XNOR using reversible quantum gates. So performing these classical computation reversibly. So these are the AND, so XOR and OR. And of course the inverse is NAND, NOR, and XNOR. So these are nothing more than these two gates. And then the OR can be performed using an XOR of the AND and the XOR, using a Toffoli gate. We will also implement a half adder and full adders. All of them will also be compared against classical computation, against classical counterparts. And then there is something called further reading. So further reading. So we will do that. Further reading, which would be like anything involving digging just about the SAT solver using classical circuits and how quantum could apply to that, or identifying the fast Fourier transform against various real-life applications. And then against these topics closely related to or like deeply ingrained with quantum mechanics like unitary groups and symplectic groups, Lie algebras. These further reading sessions will likely be of a separate season. So this is our future roadmap for today. But today, the other topic we will have to deal with is about the learning pyramid. So the learning pyramid. One thing I have to tell you is, although I'm grateful that you have subscribed to my channel, I also want to bear in mind that you have to consider the learning pyramid. Because simply listening to my lectures, my series, or in fact like any like YouTube lectures, or like even like YouTube videos and learning from that, it's just not enough. You have to apply. You have to do it. You have to do it hands-on. You may have to make some mistakes and handle failure and setbacks and respond appropriately to these to make the best out of it, to leverage from failure. That's just as Yoda says. And this time I did fail. I tried to update and upload the original Easter update videos, split them into 3. I rehearsed one of those lines over and over again until I'm satisfied. And then like I uploaded this, I then deleted these files just to save the space locally, and unfortunately over there the files also failed to upload, as upload interrupted, because it requires a local copy of the file as well for this to complete. This is my second re-recording, so I have already handled some setbacks. Let's dive into the learning pyramid. The learning pyramid is a way of understanding, identifying the easiest routes of learning and how it is not effective for knowledge and retention. So on the top level, the most surface level would be lectures. So the lectures would only be accounts for just 5% of the retention rate. So 5% of the retention rate. So this will be lectures. That means just attending the lectures or like just passively attending the class, even like if you do not know the topic initially and not engaging with it, or like even like engaging with it but then like not following up. That will be on the lectures. You can just come to the front seat of the lecture hall and then attempt to like ask these questions like, hey, raise your hands up. But if you do not follow up after lecture, like do not do the homework and stuff, it's nothing. It is nothing. It is not effective. It's the least effective way. And I have fell into that trap before. The second level is reading. This is like, it could be like anything like skimming or reading without writing notes, or like just writing some superficial notes on like a textbook, like my textbook over there, and say like, hey, I could just read everything in like 2 days and not do one exercise, or just write the notes down. Reading, it's a little bit better than just lecture, but it's still not effective. Like just learning the theory is not effective. Audiovisual. This is basically another flavor of reading, except this time it involves more interactive content, so audiovisual. This is like YouTube, engaging closely with YouTube, or LinkedIn Learning, and then passing the quizzes in like one go, or just doing some trial and error. That's audiovisual. Like graphs. Again, it is basically the same as reading. It's ultimately like surface level because it requires like no real deeper level thoughts. Demonstration is a bit better. So demonstration, because this time the instructor is actually giving a concrete real life example, like why this applies. So demonstration. For example, demonstrating static electricity by rubbing a balloon on your hair. So there's actually a technical word for that called triboelectricity, and this is one of the first introductions to understanding more deeply about electricity, triboelectricity. But again, if you just read through this demonstration or just ask questions only on that lecture, you're still only passively learning. It's still on the top half of the pyramid. How do you want to get to the bottom of the pyramid? The first step is discussion group. So 50%. So discussion group. This time, the teacher encourages students to interactively and cooperatively solve problems on their own with some teacher guidance using the topic they've taught today and previous topics. For example, in the discussion group, we learn probability, theoretical probability by rolling dice, and the students group up together and roll dice together and record how many times they got like their sum of these dice, like sum of 2 dice equals 7, and sum and the number of times the sum of the two dice equals 12. So discussion group is the first level of active learning, and it allows you to retain around half of the knowledge. Practice by doing. There's like a one-sided way and a two-sided way. And if there is an opportunity for two-sided, then leverage that. Leverage office hours, come prepared with office hours after you have solved some questions, starting from elementary questions and then progressing to more advanced questions. If you're stuck, go to the discussion group, so that includes forums or in-class activities. So forums and activities. And learn from that. Jot down some notes yourself, and then when there's opportunity, work closely with your partner or demonstrate your findings to an office hours. So practice by doing. These includes homework and office hours. So hands-on. The last level of the pyramid is teaching others. So once you have gained sufficient understanding, not knowledge, understanding of the material, you can consider teaching others about this topic, instructing others, or demonstrate a level of leadership. This involves more creative effort and may require you to synthesize related topics to help others learn. But if others want to learn effectively, they will have to learn it in a two-sided way. That means they will have to engage in active learning if they have the opportunity to do those. And like when they are, and then outside of these class hours, office hours, they should balance their time working in a group or working solo. Joining discussion groups, practice by doing, only like use the top level of pyramid if you want to learn something new. And then, or something like review the notes and making your own cheat sheet, that could possibly be also constitutes as practice by doing or teaching or instructing. But the learning pyramid, again, is something you have to consider if you want to learn quantum computing, or in fact like any subject, no matter how difficult. Or if you want to master any game like Quantum Odyssey. You cannot like simply like learn Quantum Odyssey just by watching my 50-day videos. You have to actually play the game and then experiment, especially on the red path. One of the paths requires more experimentation than the others for you to beat this game's descent mode. There's the other pyramid of learning called the Bloom taxonomy. The Bloom taxonomy lists the levels of expertise, or at least knowledge. Basically, the lowest level of cognitive learning skills like progression, the lowest level skill level would be knowledge. So lectures only give you knowledge. Reading only gives you knowledge, maybe comprehension. Lectures gives you knowledge. Reading, however, gives you some comprehension, especially if you close read. Same goes for audiovisual. Demonstration gives you application. So, how to apply this knowledge that you have in a real world or made up fictional scenario. Discussion group would provide you analysis because it allows you to understand from other people's points of views. So analysis. Practice by doing would also involve some analysis, but synthesis and evaluation, and eventually creation, so synthesis, and creation is on the domain when you're able to teach others about the subject and in a regular, consistent way. Produce new and original work. Like what I'm doing right now would constitute the bottom of the pyramid. I'm teaching you how to master Quantum Odyssey, and then I am also making some synthesis and creation on new circuits without the assistance of textbooks and only like entirely through my own experience, which is from the 75 level, practice by doing, and not through the textbook, which is just the 10% level reading or even lectures. And of course, please, please, do not simply learn through Hypnopedia. So, hip, no, pedia would be something like on the very top. Don't do that. That will be around 1% retention rate on average. Don't do that. So if you just open YouTube and then just listen to my lectures for all 50 days, you're just basically doing nothing more than Hypnopedia. What I'm doing right now is basically like teaching and instructing to you and then synthesizing new topics like that I have made up, creation, as demonstrated through the bulk of my previous sessions. Today, we will actually still demonstrate something quantum, but it will not be about Quantum Odyssey. And I will demonstrate to you and explore that learning pyramid. Next, we'll explore the learning pyramid as I demonstrate the 6 postulates of quantum mechanics and how this applies to measuring a quantum system and the Schrodinger's equation. Next, I'll demonstrate